Okay, here we want to find the area between of a region between two curves. So in this case, we want to find the area of the region enclosed by y is equal to x squared and y is equal to 2x minus x squared. Now, the first thing I want to do is notice that we don't have boundaries in this case. Whenever we don't have boundaries, we want to set them equal to each other to create our boundaries. Okay, so the first thing I want to do is just draw this so we'll have a visual representation. So first, y is equal to x squared. Remember, this is a parabola. And this is y is equal to x squared. I put it in blue just to try to color code it. Now here we have y is equal to 2 minus x squared. Now this is different. It isn't quite as basic, but remember, that's a negative x squared. So our parabola is going to point downward. And c is equal to 0, so we know it's going to go through the origin. So you'll need to use the notes and see how to graph this, or some people use a graphing calculator, but we need to go through and see how to graph this. But when we graph it, we're going to get this type of figure. Remember, we said that that is going downward. So now the area that we're trying to enclose, I'm going to put it in green. We're trying to find the area of this green region. That's what we're looking for. Because like we said, in real life, things don't come in perfect squares and perfect circles and perfect rectangles and perfect right triangles. So that's why this is important. Now from the graph, we can tell that it looks like it's going from 0 to 1, okay? But you can't really tell a lot of times. So what we do, we want to set these equal to each other to find our boundaries. So let's set x squared is equal to 2x minus x squared. Now, when we get everything on one side of the equation, I'm going to show every step. This is going to give us 2x squared minus 2x is equal to 0. We factor out a 2x. So 2x is equal to 0. So x is equal to 0. X minus 1 is equal to 0. So x is equal to 1. So this gives us our boundaries. I'm going to put it in green right here so we can just tell. X is equal to 0. And x is equal to 1. So now we have our boundaries. And I'm going to write that. X is equal to 0 and x is equal to 1. So now we can set this up. So remember, when we solve this equation, we basically look and we go the top minus the bottom. Now, we're only concerned with what's going on from 0 to 1. That's why we found our boundary. So what we want to do in this case is see which one is the top. Now, between 0 and 1, we have what? 2x minus x squared is a little higher. So let's set this up. That's 0 to 1. That's going to be 2x minus x squared. That's a slight mistake. 2x minus x squared minus x squared. Remember, that's our formula. Now, when we simplify, that's going to be 2x minus 2x squared. Okay, and now it's time to find the antiderivatives. The antiderivative of 2x is going to be 2x squared over 2, which simplifies to x squared. The antiderivative of 2x squared is 2x cubed over 3. Of course, this ends up being just a classic definite integral. So now let's just set this up and solve it algebraically, and let's show every step. Of course, we know when we put 0 in, that's automatically 0. This gives us 1 minus, remember, follow the order of operations, 1 cubed times 2 divided by 3. That's 2/3. 1 minus 2/3 gives us 1/3. And this is how we find the area between two curves, and how we specify when we are not